Welcome today. Allow me take you through chemistry practical, the year 2017, the Kenya National Examination Council, Kenya Certificate of Secondary Education. Please allow me and take you through paper 3, the year 2017, as you can see. You are provided with a solution A, 0.5 molar copper 2 sulfate, solid B1, metal B1 powder, solid B2, iron powder. Solution C is 0.2 molar acidified potassium manganate 7. You are required to determine enthalpy change for the displacement reaction between metal B1 and copper 2 sulfate. Mass of ion that react with copper 2 sulfate in the displacement reaction. Procedure. Using a pipette and a pipette filler, place 25 centimeters cube of solution A into a 100 plastic beaker. Allow to stand for about 1 minute, and then measure the temperature of the solution. Record the reading in table 1 as the initial temperature. Add all solid B. Add solid B to the solution. Start a mixture carefully with the thermometer. Measure the highest temperature reached. This will take about 5 minutes. Record the reading in table 1 as the maximum temperature reached. So I want to give you the values. The maximum temperature reached when the experiment was done was 43.5. Initial temperature, room temperature, was 25. And then when you subtract this, you will get 5. 18. I have kept the decimal point, so once the table is filled up, you get 1 mark. Use of the mass subtraction, you get another mark, and then the decimal point. It is either you will keep a whole number 43, or you may round off to this, or you write in whole numbers avoiding the decimal point, but you can use the decimal point as well. So that is what was expected. Calculate the number of moles of copper 2 sulfate used. Calculate the number of copper 2 sulfate used. So I want to take you back to what we were provided. We were provided with 0.5 molar. This is the number of moles in 1 liter. Therefore, we can easily get the number of moles. Remember, we used 25 centimeters cube of the solution A, which is solution A, 0.5 molar. So we will ask if 0.5 is the number of moles in 1000 centimeters cube. What about 25, the one that was used? We know that 0.5 capital M means that implies that 0.5 is the number of moles which are in 1 liter. Then we ask, what will be the number of moles in 25 centimeters cube of solution A that was used? So it is 25 times 0.5 divided by 1000, and this one is going to give us 0.0125 moles. The enthalpy change for the the question is here, calculate the enthalpy change for the reaction of metal B1 with 1 mole of copper 2 sulfate. Assume that the mixture specific heat capacity is 4.2 and the density of the solution is water. So here we start by calculating the heat change. Heat change is given by the mass of the solution times specific heat capacity, we use capital C, and then times the temperature change. The solution that was used was 50 centimeters cube. So this 50 centimeters cube is as good as 50 grams of the solution. Now you convert these grams, because we are using the mass of the gram. You convert this from grams to kilograms by dividing 1,000. So we will have 50 divided by 1,000. This is the mass. Specific heat capacity is 4.2. 4.2 times temperature change. Our temperature change was 18.5 times 18.5. And this one, you multiply this, use your calculator, and it will give you 1.9425 kilojoules. We have used mass in kilograms, therefore we are going to have kilojoules. Okay. Now the next thing is to calculate the molar heat capacity, molar. So we know the number of moles that produced this amount of heat. This number of moles of the copper sulfate was able to produce this amount of heat. Now we want to ask, what will be 1 mole, because we want 1 mole we produce. So you will ask that 1.9425 kilojoules were produced by 0.0125 moles. 1 mole will give us what amount? This times this divided by this. So 1 times 1.9425 divided by 0.0125 will give you 155. Use your calculator. 155.4 kilojoules per mole. Kilojoules per mole. But now you ask yourself, was the reaction exothermic or endothermic? Our reaction was exothermic because temperature increased from 25 to 43. Therefore, our final answer is negative 155.4 kilojoules per mole, because our reaction was exothermic. The temperature was increasing from room temperature 25 to 43.5. Therefore, the reaction was exothermic. Let us go to procedure 2. Repeat procedure 1A, Roman 1, with all the metal B2 iron powder in place of metal B1. The maximum temperature is reached after about 8 minutes. Record the temperature readings in table 2. Retain the mixture for use in procedure 2. So the maximum temperature reached during the experiment was 37.5. Our initial temperature by that time it was 24.0. So when you do the subtraction, you will get it is 13.5. 13.5. And you get your 3 marks there. The next question is, compare the change in temperature between change T1, temperature change 1, and temperature change 2, and comment on the differences. So we want to compare the temperature 2. The change in temperature 2 is 13.5, and the other one was 18. So that simply tells you that change in temperature 1 is larger or is higher than change temperature in 2. That's what you can see. So that is what you are going to observe, that change in temperature 1 is larger. You can use larger or is higher than change in temperature 2, because you can see this is 13 and the other one was 18. T1 was 18, T2 is 13. Now, what are you going to comment? We are going to comment that metal B1 is more reactive. It's more reactive than metal B2. Hence, greater temperature change. Temperature change. Now let us look at the titration part of it. Procedure 2. Fill the purate with solution C. Remember, solution C is potassium permanganate and it is 0.02 molar. So that is something that you must always try to remember from what you are provided with. Remember, you are provided with, where that? Here. You are provided with solution C is 0.02 molar acidified potassium permanganate 7. Don't forget that. Filter the mixture obtained in procedure 2B. Procedure 2B is where we had iron displacing copper into, so put that mixture, if you filter the mixture and then put the mixture in a 250 volumetric flask, wash the residue with distilled water and add it into the flask. Add more distilled water to make up to the mark. Label this solution B2. So here you need to understand this, that what was B2 and so B2 was iron. Iron will react with copper 2 sulfate, whereby iron is more reactive than copper, therefore it will displace copper to form iron 2 sulfate plus copper. Copper will be displaced. So now we have this solution. We have filtered this solution, iron 2 sulfate. Now we are putting this solution into a volumetric flask and then add distilled water to the mark, where we will have a total volume of 250 centimeters cube of iron 2 sulfate. So we are going to react iron 2 sulfate with acidified potassium permanganate. Right? That is the understanding you need to have. So using a pipette and a pipette filler, place 25 centimeters cube of solution B2. Remember, this is a solution which contains iron 2 ion. That is what you need to understand. Into the conical flask, titrate solution B with solution C until a permanent pink color just appears. Very correct. So this is, remember, this one is an oxidizing agent, so it is going to oxidize iron 2, and then we are going to see. So when the permanent pink color appears, just appears, then we record our table. So these are the values that we want to use. We want to use 22.5, 12.2, and then we are going to use 24.5. 24.5. Here the initial, we can even start at 10. It was started at 10. Initial here is 0.0. Initial here is 12.2. So this, I want to show you that it is not a must that our initial is always 0. Initial can be any volume. It is you to decide. So initial is not a must that it should start 0. So when you do this math, you get 12.5. This one is 12.2, and this one is 12.3. So calculate the average volume of solution C used. Now this is the average volume of the potassium permanganate solution. Now because I can see this one is somehow far away from the range of plus or minus 1, so minus 2, I want to leave it out, and I will do the average with only these two. I will do the average with these two, so to be accurate, more accurate. Therefore, I will get 12.2 plus 12.3. You divide it by 2, and this one will give me 12.25 centimeters cube. Let us look at this question. The equation for the reaction between manganate 7 and iron 2 ions is as follows. You can see then this is the manganate and this is the ions, and then the acidification of it. Yes. So calculate the number of moles. Calculate the number of moles of potassium manganate 7 used. The number of moles of potassium manganate 7 used. But we know that 0.02 is the number of moles in 1000 centimeters cube. Solution what? Solution C. Remember that because we were provided with 0.02 molar potassium permanganate. So we have used 12.25. So we will ask 12.25, this volume here. We have used 12.25 of solution C. Solution C, acidified potassium permanganate. So we will ask, what will be the number of moles of this 12 centimeters cube of solution C? What will be the number of moles? So this times this divided by this. That one will give us 0.0000245 moles. So this is the number of moles. It is the number of moles of potassium permanganate. But the ratio between potassium permanganate and the ion is 1 to 5. So the question, calculate the number of moles of iron 2 ions in 25 centimeters cube. Solution B. 25, the one we pipetted. Now, since this is the reaction, we know 1 is equal to this moles. What about 5? Now, mole ratio between the iron and the manganese is 1 to 5. So we just simplify, we multiply this times 5. So moles of iron 2 equal to 1 equal to 5 times 0.000245, which is equal to 0.00122 moles. So this is the moles of the iron in 25. So because 25 centimeters cube is the one that reacted with 12.25 solution C. So those are the things you need to understand. Now the next we calculate the number of moles of iron that reacted with copper 2 sulfate. I have already showed you the reaction that took place. The initial reaction that took place is that copper 2-sulfate was displaced by iron to form iron 2-sulfate plus what? Plus copper. And then this solution was added water. This solution was added water to make 250 centimeters cube. So, and this is the iron. So if 25 of this iron, 25 has these moles, what will be the number of moles in 250? The one that reacted with the copper. So you just simply ask 25 centimeters cube of the iron is 0.001225. What about 250 centimeters cube of the iron? What will be the number of moles? So this times this divided by this, and that one will give you 0.01225 moles. Yes. Determine the mass of the iron. Determine the mass of the iron that reacted. Now we have the RM of the iron as 55.8, but we know that mass equal to moles times RAM. Sorry. The number of moles of the iron that reacted with the mass. Determine the mass of the ion that reacted. The mass of the ion that reacted with copper. We have the number of moles of the ion. Yes, we have the number of moles of the ion. Therefore, we have the RM of the ion. We just get that it is these moles times 55.8, which will give you 0.6836 grams. That is the mass of the ion that reacted with the copper. The qualitative part of it, 2017, the qualitative analysis. This is the practical that gave most of the students a very big challenge, because here, unlike other years, they were supposed to write the test for themselves and then give the observation. They write. So so many people or students did not get this right, because actually they were supposed to write the test. If somebody does not know the test, then the observation cannot be made. So let us look at the question itself. You are provided with solid K, aqueous ammonia, aqueous sodium sulfate, dilute nitric acid, and then wooden print. Solid K is suspected to be lead 2 carbonate. So you should understand the behavior of carbonates with the acid. Whenever you add an acid to a carbonate, you expect effervescence. So if you don't understand those kind of information, then you are likely to be left out in this. So from the reagents provided, select and describe 3 tests that could be carried out consecutively to confirm if solid K is lead 2 carbonate. Write the tests and expected observations in the places provided. So the first thing you want to do is to test whether indeed when you add HCl to the solid provided, it will give effervescence. If it will produce effervescence, then you are likely to say, yeah, this one could be the lead carbonate. So the first test is that you add you can add 10 centimeters of to the you can even start it at 2 solid K in a test tube. Add about 10 centimeters cube of dilute nitric acid provided. dilute nitric acid provided. And then you retain the reaction. So you tell that retain the reaction, the mixture. Retain the mixture for tests. For tests 2 and 3. So when you added 10 centimeters of dilute nitric acid to solid K, what did you see? If indeed it was a carbonate, then you expect what? Effervescence. Effervescence occurs. Another observation is that a colorless gas, because you are given a wooden sprint, now you will use that wooden sprint. This gas, will it extinguish the wooden sprint, or it will rewrite, or what will happen? So a colorless gas, we expect carbon dioxide to be produced. It is the carbon dioxide which will cause effervescence. Therefore, we know carbon dioxide does not support combustion. If you introduce a burning sprint, it will go off, it will extinguish. Therefore, a colorless gas is produced. A colorless gas that extinguishes a burning sprint. A burning what? Sprint. Let us go to test number 2. So with that one, we have, these are the things we need to confirm, that we know that if I had this one, will produce effervescence, and effervescence is produced because of the carbon dioxide gas that will extinguish a burning sprint when it is introduced to it. Test number 2. Now we have the reagent aqueous ammonia and then sodium sulfate. You have seen most, you cannot test for, you cannot use the aqueous the sodium sulfate before you use ammonia. So most ammonia will come before the sodium sulfate. Therefore, we now take about 2 centimeters of this mixture to about 2 centimeters cube of the mixture in Roman 1, in 1 above. Add to about 2 centimeters cube of the mixture in Roman 1 above, add ammonia solution, aqueous ammonia solution, dropwise until in excess. So because we are expecting lead, what happens when lead, when ammonia is added? Suppose lead was in that solution, what will ammonia do? Ammonia will form a white precipitate, and that white precipitate will be insoluble in excess. Remember, ammonia, when you add ammonia dropwise, a white precipitate is formed, and in excess the white precipitate dissolves to form a colorless solution that confirms zinc ions. But if it does not dissolve, then there are other ions inside, like aluminium, like these others. So here, the observation is that white, because we are suspecting lead. So lead is among the amphoteric. So a white PPT is formed. A white PPT formed insoluble in excess. Yeah, because we know that if it was lead, it will form a white precipitate which is insoluble. That is ammonia. But if it was zinc, it will form a colorless solution in excess. a colorless solution in excess. A colorless solution in excess. Let us go to test 3. Now to about 2 centimeters cube of the mixture in Roman 1, add 2 drops. Add 2 drops of aqueous sodium sulfate. We are adding sodium sulfate. We expect that the sulfate will combine with lead to form lead sulfate. Therefore, here you are expected to write a white precipitate. White PPT is formed. White PPT is formed. Now, up to that point, you have confirmed that this one could be actually lead carbonate. Could be lead carbonate. Now, part B, carry out the test described in A using solid K and record the observation and inferences in the places and the spaces provided. Now here the students were required to now carry out the experiment using the test the test they have described. So they were supposed to first, so you see in the first one, solid K in a test tube, add about 10 centimeters. So that is now what they were supposed to do it now practically, so that now they could make this observation. So majority they did not understand that. I think that's why they failed very much this year, the practical part of it. So here they were supposed to carry out this now practically. Remember, this one was just being written, showing the understanding you have in these things. But here they were supposed to do it, and then state the observation and then the inferences. So here the observation was, as we have said, that effervescence occurs a colorless gas extinguishes a burning sprint. So you are supposed now to give the inferences of what you have observed. So definitely, if an effervescence occurs and a colorless gas is produced which extinguishes a burning sprint, then that tells you that it is a carbonate, and then you write the CO3 2 minus present. Test 2. What was the observation? Now you do the test 2 using the procedure that you provided. To about 2 centimeters of the mixture above, add ammonia solution dropwise until in excess. Because now this one you are doing it practically. What will you observe? What was the observation? The observation was that a white precipitate, a white PPT that was insoluble in excess, that was insoluble in excess. Now here we would want to challenge, because here if it was insoluble in excess, from the amphoteric we know we have the ZAP, the zinc ions, the aluminium, and the lead ions. Yeah. So because a white precipitate was formed which is insoluble, inside here could be so many. So here could be lead, yes, Could it be magnesium? Could it be barium, aluminium, and the rest? But we are going to cancel some out. Remember, we are going to say that aluminium carbonate, why I'm not going to allow aluminium, or aluminium carbonate is not there. Do we have aluminium carbonate? Because we have said that carbonate is there. Aluminium carbonate does not exist. Therefore, aluminium is taken out. Right? Also, we can also, also what I'm leaving out calcium, 2 ions, calcium ions. Calcium ions are also present. So, what we are going to say, calcium cannot be precipitated by a weak base ammonia. Therefore, calcium ion will be disqualified from there. So, what we are going to remain with is magnesium, 2 positive, and lead present. Magnesium, 2 positive, lead, 2 positive, present. Test number 3. Now, when the test was done practically, solid K proved that no, when we did this, when this was done, to about 2 centimeters of the mixture, that was solid K that was dissolved, add 2 drops of aqueous sodium carbonate. Here we say the white precipitate is formed because we didn't do the experiment. But on doing the experiment, this was the observation. No white PPT was formed. On doing the experiment, there was no white PPT. So if there was no white PPT, then it means lead ions were not there. Because if the lead ions were there, they could form a white precipitate. But since, so here we say magnesium 2 was present. Or you can say lead 2 positive was absent. It is acceptable. Was absent. So these are the observations on doing the experiment using the solid K. Using the solid K. This one, the students were required to show that they know what happens when we have a carbonate. Thank you. Let me take you to the last part of it. The last part, we had the organic. The last part of it, we had the organic. You are provided with an organic compound. Here you have been told that you have organic compound solid M. Right? That is a very important information. You are provided with an organic compound solid M. Carry out the following test. Record the observations and inferences in the spaces provided. Place all the solid M in a boiling tube. Add about 10 centimeters cube of distilled water and shake. Retain the solution for the use in the procedure B, Roman 1, Roman 2, and Roman 3. So, here we want to state the observation. Did the solid M dissolve in water? Yes or no? So, the solid dissolves, forming a colorless solution. Since we know it is an organic compound, then now we say a polar organic compound. Yeah, a compound which is organic and it dissolves in water forming a colorless solution, it means that that compound is polar. Because water is polar, therefore it has to mix in another polar organic compound, another organic or polar substance. Use about 2 centimeters of portion of mixture in the test tube for tests 1, 2, and 3. So, to the first portion, add all solid sodium carbonate provided. I have always told you that whenever you are adding sodium carbonate, this is a carbonate. If the solution is an acid, you will expect effervescence. If the solution is not an acid, you will not see effervescence. Therefore, you know what to say. So here, solid carbonate, you expect effervescence or no effervescence. So here in this case, there was no effervescence. There was no effervescence. If there is no effervescence, it means that the organic compound was not an acid, was not an alkanoic acid. So therefore we say RC, this is the functional group of alkanoic acids, was absent. If this one disappears from your mind or you forget, you can write the hydroxonium ion, it is acceptable. Absent. You can say this, absent. To the second portion, add 2 drops of acidified potassium permanganate, warm the mixture. Remember, acidified potassium permanganate is purple, so the purple acidified potassium permanganate is decolorized, meaning that the purple color changes to colorless. The purple color changes to colorless. That's what it means. So if that happens, then it means that there is a double. That organic could be a double. Could be an alkene or an alkyne. Please avoid writing alkene or alkyne in words because they usually ignore that. Or an alcohol is present. Or an alcohol is present. This one we write all of them, the 3 of them. They could be present when purple acidified potassium permanganate is decolorized. Then these 3 are expected or are suspected to be there. To the third portion, add about 2 centimeters of acidified potassium dichromate. Heat the mixture to boil and allow to stand for about 2 minutes. Then the color changes from orange to green. So that confirms that the alcohol is present. That confirms the alcohol is present. So how else can you state it to observation? You can say that the orange, the way you can state this observation is that the orange acidified potassium dichromate, the orange acidified potassium dichromate changes to green on warming or on heating, whichever, on warming. So this one is present. Thank you. I want to appreciate your support. I want to appreciate your support very, 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 very. Please, thank you for your support.